All right, test 1, 2, 3, test. Here we go. All right, hi everyone. It's Leo Rudberg. I'm doing a video recap of how my Git tutorial went. This is on behalf of the UPL video lecture series. UPL, it's University of Wisconsin-Madison's undergraduate projects lab. It's a really cool place. If you're on campus, you should check it out. We're just a bunch of friendly hackers. So I wrote up this gist of how my lesson went. It's on GitHub. Here's the link. I'm not going to repeat all those numbers. Just look for me. Look for my gists. Yeah. I'll put this in the description of the YouTube video when I put it up there. Yeah. So, I made a short slideshow of how this is going to go. You should check that out too. The link's in there. So let's get started. So, I'm assuming that you have a Unix-like terminal. I'm not familiar with how Windows, the command prompt works there, but you won't need too much terminal mastery to get this tutorial done. So if you see a $ like this right here in some code that I write, that you don't have to enter the $. That's just showing that's prompting you for input. Like I said, you just need minimal terminal knowledge. So cd, change directory, pwd, print working directory, ls, list maybe? I don't know. It just shows all the files that are in your directory. Make directory and open. So that's all you need to know for this tutorial to get stuff done. I'm going to use Vim later on. It's just a text editor. Feel free to use Sublime Text or TextEdit or Notepad++ if you're on a PC. But yeah, this shouldn't require too much technical depth. So there are GUIs for Git, but I prefer using the command line just for the stuff that I do. I also prefer command line because it's easy to do over remote connections, which I'm doing a lot these days with web development. So the first thing you should do is start this tutorial by creating new directories. Actually, the first thing you should do is check that I have Git. So just to check that you have Git, just type git -- version into your terminal, and then you should get whatever version of Git you're running. This means that you have Git. If you get some weird error message like Git is not a command or whatever, that means you probably don't have Git. So just run a homebrew command, or download it using the git scm.org website. They'll tell you how to install it for your machine. So the first thing we're going to do is let's create some directories. Something that I did during this tutorial, something I didn't do during the tutorial was highlighting this step, so people ended up doing a lot of stuff in their home directories and root directories, which is not good. So first, let's create some directories. So I'm going to make a directory called git tutorial. And then I'm going to go into that directory. All right, so I'll just do an ls. Okay, it's empty. Oh, okay. So yeah, it's definitely empty. So now I'm going to make a directory called phase1, just to do the preliminary stuff. I'll just phase1, and then I'll go into that directory. That one obviously should be empty too. So the first thing we're going to do is run git init. That will make the phase1 directory a Git repository. So git init, simple as that. You can see it gives me a success message here. So if I do ls-l, I think it's al, show me everything. Yeah, cool. So we can see our .git folder shows up. So that means that Git is going to start tracking all the changes we make in this folder. So first thing, another useful Git command is after init, you run here up there, so you don't see all that stuff. Is git status. So let's just talk about what information this shows. It says we're on the master branch, so I'll talk about branches later, but we're on the main branch. It's the initial commit. We haven't done anything. Obviously, we have nothing to commit. We have no additions. It's just saying use git add to track changes. So just run a git log Oh, okay, cool. So that's awesome that failed. I'll talk about git log later. So status just tells you what changes are happening in your Git folder. So we're gonna run it. We're gonna open up a new file. You can just do this really quickly using the touch command. It's equivalent to just opening up a new file in your favorite text editor and leaving it blank. So I love git.txt because I love Git. All right, so we'll do ls-l. Okay, cool. So now we have our I love git.txt file. So now we'll see how that affects Git status. Cool. So we're still on the master branch. It's still initial commit, like we haven't done anything. We do have an untracked change though, since we just added the I love Git file, and it shows up here in red saying, "Hey, you're not tracking this yet." So let's track it using git add. I could have also done that using git add dot. Yeah, and then later on, when you start editing like hunks of files instead of just the files themselves, or just parts of files, I mean, you can use git add patch, and that'll add in hunks, and you can use that as a good way to rubber duck your files, meaning that you can see all the changes you're making, kind of think for a second, like, hey, does this line make sense? So that's what I use. I use patch a lot. So now that we have our file, let's just run a quick git status again. Cool. So now we're tracking it. Git says we have a new file. It's called I love Git. Makes sense since we just added tracking on it. So let's commit it. And commit just means that we're saving it. We're kind of creating a checkpoint in our project, in our Git directory. So if we just run git commit without a git commit message, or without a commit message, it'll give us an error. Or it may just open up our text editor and make us write a message. But the shortcut is just to supply a -m argument, and then whatever's after the m in quotes. I use quotes. I think you have to, but whatever inside the quotes is your commit message. So the canonical way to do it is just initial commit. That's what you call the first one. You can call it something else, but that's what everyone does. All right, awesome. So our commit was successful. We added one file. We didn't insert anything. We didn't delete anything, and it just added tracking. It added tracking to I love git.txt. Cool. So let's see the next step. So let's work on pushing. So Git is distributed. I talked a little bit about that in the slideshow. And distributed means that you can push and pull from the kind of central repo, the remote repo. So let's go to GitHub and start up a new repo. All right, this is what happens when you follow a lot of people on GitHub. So let's create a new repository. I'll just call this my, I don't want it. See, they supply you with a funny name there. Yeah, I'll just do my fun tutorial, because it is fun, obviously. I'm going to just say tutorial for basic Git food. It's public. So the difference between private and public means that it just, as your code visibility, you can see the GitHub descriptions here. I don't want to do any of the advanced settings. I don't really care about that stuff for now. So I'll just create the repo. Awesome. So Git is telling me a bunch of commands I can copy and paste into my terminal that will get everything set up. Let's just see what I tell myself to do. I did just set up a vanilla repo. Okay, cool. So I'm gonna look for the git remote add u option. I should fix it. That's not actually what that says. So run this option. I'll fix that in the gist later. You want to run this middle option because we have an existing repository on the command line. We don't do this one. Don't do this one. Do the middle one. So git remote add origin and copy paste. So this is basically just saying we're going to add our remote repo to this project, and it's based on GitHub at this URL. And I talk a bit about my about why I use GitHub. Actually, I don't talk about that in the presentation, but I do mention that there is another service called Bitbucket, which is similar to GitHub. They do their private repos a little bit differently. Actually, it's more friendly towards students, since you can have a bunch of private repos. Instead of just GitHub gives you 5 if you're a student, you can have as many as you want on Bitbucket, but Bitbucket limits the amount of contributors you can have on private free repos. So that's just something to think about. Bitbucket's fine. I prefer GitHub, but I might be switching to Bitbucket for my school-related stuff. So anyway, I'll run this command. Okay, cool. It's called like silent success. Nothing bad happened. And then we'll push. So let me just enter this command. Virgin master. Okay, so let's see what this does. So pushing will push my local changes to the remote repo. So I call it the blessed repo. So that's like I call it blessed because that's where you want to put all of your good code. If you're doing something experimental, you know, a feature that may or may not work, something that you haven't tested yet, do it locally. Don't push it to the repo because other people will be pulling from that the blessed repo, and if you put, you know, like tainted code in there, that could end up causing problems for your fellow developers. So you don't always respect the blessed repo. So yeah, we're gonna push. You should get an awesome message. Cool. Okay, so it basically just said it sent it. You can see that we set up a new branch. It sets up a new branch on the remote for us called master, which is basically a mirror of what we're doing locally. Cool. So that's successful. Remember, kids, the mantra for Git is edit, add, commit, and push. So that's basically what we just did. So another thing, so the opposite of pushing is pulling, and that's when, let's say, you know, Alice, she makes changes and she pushes it to the remote. How do you get Alice's changes into your project? Pull them. So if we do git pull, obviously we just pushed, and we are the only ones working on this project, so it's up to date. But you should know about pull. So git checkout is another cool command. I use it for 2 things: undoing bad and dirty changes and switching branches. So first of all, let's say, you know, your evil friend Oscar, whatever, he's a bad guy. He tells you that RM actually means run magic. It makes all your code work perfectly. So you say, okay, I'll just do RM I love Git because that will write my program for me. But then, oh no, it actually deleted it. Well, we can fix that by, so we'll run git status. I have that alias to GS in my bash profile. So git, you know, says, hey, you just deleted this thing. So if we just run git checkout, I also have co alias to checkout. Git checkout, I love git.txt. Hey, it's back. It's still empty, but it's back. So everything's fine. If we run git status again, we can see that nothing to commit. There's no changes, so we're back to normal again. So then we also have the concept of branches. So if we run git branch, that'll show us all our branches. We only have one branch right now. It's the master branch. That's kind of like the trunk of our tree. But we can also create other branches to work on, you know, additional features and stuff. If we want to test some code and we don't want to put it in our blessed trunk, you know, our local one, we can kind of use branches to avoid messing up our central repo or our central branch. So let's do git checkout -b my branch. Cool. So if we run git branch again, which just lists, all git branch does is list the branches that you have. We are now on the my branch. Cool. So if we make a change, you know, we'll do touch my branch file.txt. this will create a new file called my branch file. We run git status. It shows that we have an untracked file. Let's, what do we want to do? I forgot my own tutorial. All right, cool. So add and commit. So git add my branch file, and then git commit. We'll say added branch. Cool. So nothing to commit. Everything's good. So now our my branch, the branch is one step ahead of the trunk. They've diverged. Luckily, we've only done a fast forward diverge, meaning that the trunk is just a subset of the files or changes in the branch. So we can just apply all the changes in the branch to the trunk, no problem. So let's say we're done working on the branch. We want to go back to master to merge everything back in. So let's run git checkout master. Cool. So now we just switched back to the master branch. We can show that we did that by running git branch. This one's green. It has a star next to it. That means we're on it. So then we just run git merge my branch. Dang it. Why doesn't this have autocomplete? So now we're just going to apply all the changes that were on the branch to the master. Cool. So it was a fast forward saying all we did was add my branch file.txt. Everything's good. Everything's copacetic. So that was easy. And do we need to commit anything? Awesome. We're still ahead of the remote by one commit, but we don't care about that for now. So now let's do a three-way merge. So this is a tricky merge. It means it involves multiple people or multiple repos, not just kind of one local and one remote. You should follow these steps. I'm just going to go through it quickly, but you should find a friend and do this with them. It's a fun way to learn how three-way merges work. So I'm going to treat this this terminal as A, and then the second one as B. So, what? Why is this at the bottom? Okay. What is this doing? Okay. So here's what we're gonna do. So A is gonna create a new file called. So we're on master. Yes. Okay. So we're gonna create a file called mymerge.txt. We're just gonna run touch. All right. So then we're gonna add a line called. We're just gonna add the line octopus to it. I use Vim. Nano's fine too if you're uncomfortable with Vim, or you could use Sublime as long as it's a good text editor. You know, whatever text editor you want. So I'm just going to add the line octopus to it. Cool. So then I'm going to have let's see. Okay, so this file's untracked. I'll git commit. This means add commit. What? Oh no, I did something wrong. Git. I'm sorry. All right. Awesome. Okay, so we just added that file. Let's make sure. Awesome. Cat my merge. Okay, cool. So now we're going to push this to the remote, and then B is going to clone this. So I'll go up, and I'll just say this is make a new directory called person B. cd into person B. All right, cool. And then I'm going to clone this on GitHub. Basically, that means I copy the repo from the remote. So luckily, let's refresh this. Awesome. So we can see our latest changes in there. I'm just going to run a git clone. So this just says create a new repo from this repository. And I'll just create it in the local one. So that's why I add the space dot after it. Cool. So this is, for example, this is Bob taking over Alice's, or this is Bob using Alice's previous code. So let's see. Okay, so now Bob is going to change Alice's line to Octodad. Cool. And then, so Bob thinks this is the better change. He thinks, you know, who wouldn't want to turn Octopus into Octodad or whatever. So Bob's just going to go ahead and push the code. So first of all, we have the change. I'll just show what a patch looks like. So git add -- patch. So it just says, here's the line you had, or here's the line you had previously, and here's what it looks like now. I'm going to say yes as Bob. That looks good. Add it. Cool. So we see that screen now, and then we'll do git commit person B changes to Octodad. Cool. And then so now Bob is going to push that because he thinks it's good. Awesome. Let's see if that took effect in the repo. Yeah, okay, so now it's Octodad. Cool. And we can actually see the history if you want to take a look. It was just like our patch shows right there. Cool. So now A is going to say, oh, wait, hold on. I wanted to change that, this one line. So now Alice is going to change Octopus to Octocat. And Octocat is the logo of, or it's the mascot of GitHub. You can look into that. There's some cool drawings that GitHub has. So I'm back as person A, Alice. So I'm going to do vim my merge.txt and say I no longer want an octopus, I want an octocat. I'm going to do the same thing. I just have this as clear, or I'll just do gap git add patch. Status, okay, cool. Git commit, say like all right, cool. So Alice thinks that this is good, and now she's gonna push it. So you can see it got rejected, which is actually what we want. That's because Bob pushed his code in before Alice had a chance to push her correction in. So now she actually has to pull, which is, so this is gonna take Bob's code from the remote and put it on Alice's computer. Cool. So now we just pulled. It's telling us a bunch of reports, blah, 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 blah. And then all of a sudden you see this big conflict here. That means that there's a merge conflict in my merge.txt, which is what we wanted. So now we're going to fix this. So you could run git merge tool. That will pop up something. I can actually show it to you right now. So I'm just going to clear my terminal. Git merge tool. And on a Mac, this will probably open OpenDiff. Meld is a good one. I've seen a professor use it, and it looks good. So you can just see here's the change. So this is what we have locally. This is what we have originally, and this is what we have on the remote. basically it's a three-way merge because we have three different editions of the line of code or whatever. So we have to choose whether we want Octocat or Octodad. Let's say we want Octocat because of GitHub. We want to choose the left one. So if we wanted to apply that change, we just click save and it'd be done. But let's just cancel it. Let's say we don't want that, and I'll show you like the original way to do it. I actually only learned about this a few weeks ago. I've seen it in the code. I've seen it in code before, but I just always defaulted to using either vimdiff or opendiff, whichever one was easiest to use. But I'll just show you what the merge conflict looks like actually. So we'll open up my merge.txt, and you'll see that there's this weird notation now. So we originally had Octodad as the we wrote Octocat as person A, Alice, but then Octodad is what we got when we pulled. So let's say we want Octocat. We can just edit this weird syntax ourselves, and it will go away. And so they unmerged paths. So now we just want to add that to fix the merge conflict. Run git stats again. So we can see we fixed our conflicts, but we're still merging. Your branch have diverged. So I'll just read what I have to do. Okay, so cool. So it's telling us we have to commit. So git commit fixed merge conflict. Awesome. So we fixed the merge conflict. Yay! Oh yeah. So this is what you have to do if you don't have a default merge tool. So we've been racking up the commits like true top coder ninjas. So let's look at what we've had in our log so far. So this is where the commit messages come in. I can close this one right now. It's not too useful anymore. So this is what our log looks like. It does it in reverse order. But there's probably some way you can change it from top to bottom if you wanted to. There are also other ways to do it. There's like short log and one line. But this is the default log, so we can see who made what commits when. There's my email. Please don't spam me. But yeah, so you can see all the changes, what was made, the special hashes that correlate to all the commits. So yeah, there we go. Oh, you can see we had a merge. That's cool. Oh yeah, and it gives the hashes that of the commits you merged. That's nice. So now I'm just going to talk about some other commands that are nice. We don't necessarily need to type anything. So I talked about log. Clone is what I used for the person A, person B three-way merge thing. It basically just clones the repo into whatever folder you want. And when I say clone, that means it's an exact replica of the repo at a certain commit in time. So in contrast to cloning, there's also forking, which is you basically clone, but then you kind of gain control of the repo. So for example, if I wanted to fork, if I wanted to make Leo Nux, that totally rolls off the tongue. And I thought, oh yeah, Linus did a pretty good job, but I think I could do better. I could fork the Linux project and start working on my own and make commits to my own repo. It wouldn't go back to Linux Linus's repo because I think that my stuff is superior and I want to, do proprietary stuff or whatever. I don't know. But, so yeah, forking will basically give me my own version of whatever I'm forking, and I'm in control of the repo now. whereas cloning, if I pushed code, it would go to the original Linux repo. I also think git blame is awesome to talk about, only because at UW-Madison, our own Professor Ben Liblet, he made the predecessor to this back when everyone was using SVN. So git blames has a special place in my heart for that. It's also awesome if there's a line of code that's broken and you want to shoot Nerf darts at whoever introduced that broken line. So, for example, we can do a git blame on our my merge to see that I made the change at this time, and you know, here's, you can give the time zone and all that stuff. So yeah, it says me, LOZORD, made the change at this time, this date, on this commit hash. So if this line of code makes you angry, feel free to shoot Nerf darts at me. So now let's talk about some other miscellaneous git commands. There's git gc. I just like to run that occasionally, kind of when I'm bored, I guess. That just garbage collects your git repo. You shouldn't need to do it as a beginner. It's really if your project gets big and gets, you know, slow. It's just a good thing to know in case Git's being slow, but it shouldn't happen. This is my this is what I call the nuke command. So let's say you were working on something and you just got totally lost. You don't know what's going on anymore. Your code's totally borked. You just want to start from the latest, or from the last commit. Run git reset --hard head. This basically undoes everything that you did since the last commit. So that'll get you back to your last commit like nothing ever happened. Git clean will also delete untracked files. So let's say you run something, you know, you run like you compile a Java thing or a C thing or whatever, and it barfs out a bunch of executable files that you don't want. You could just run git clean and it will clean those up. It will just remove them. Something that's good to do is run git clean -- dry run, and that will do a that will tell you everything it's about to delete. Obviously, we're not going to delete anything. But if I wanted to just do touch dumb file.txt, it would say, since we're not tracking the dumb file, it would do that. Git clean is a useful command. Something that I also like to do is, let's say I like some code I have, but you know, I want to pull in. Excuse me. Gesundheit. Let's say I want to pull in someone's code while I'm working on something, but I want to kind of push my code off to the side, work on theirs a little bit. There's a really cool command called git stash. Not like a mustache, but like kind of like a secret stash of things. It's a stack that holds changes to your Git folder. So if we run git stash, oh no local changes to save. So let's just edit my merge.txt. Let's just say Bucky Badger. So let's say I don't know if that code works or not. I need to do some other stuff in the meantime, but I'll put it on the stash. I don't want it in the main project right now. It'll go back to the last commit and remove any changes I last did. But the changes still exist, but they're just kind of on the stack to the side. So if I do cat my merge, you'll see that it doesn't say Bucky Badger. But if I do git stash -- list, I'm sorry, git stash list, it shows that I have something on my stack, and if I, just like a stack, I can pop it. So git stash pop, it just shows that I have a bunch of stuff changed. So if we do git my merge.txt, we get Bucky Badger back. Yay, go Badgers. So that's all I got for you now. I list some commands at the bottom that explain how to remove this stuff, just in case you did it in your root or home folder. which some people did at the tutorial, which I feel sorry for not saying earlier. You can run sudo rm-rf.git or /.git, which will remove the Git folder in your current directory. So that'll make your it'll delete all the Git tracking on all of your files, but it won't delete any of your files. Also, you can just delete the files themselves. And I just say do this with. I just want to give a warning because there's a command that kills your computer. It's called sudo rm-rf --no preserve root, and that will literally turn your computer into just a metal box. It deletes the OS, it deletes everything. So just be careful. If you're scared, just ask your friendly neighborhood hacker. But otherwise, that's all I got. Thanks for watching. I hope you enjoyed it. Feel free to comment or reach out to me if you have any questions. You can comment here or on YouTube or wherever we post this video. Git's an awesome tool. It really makes my life easier. I hope it makes your life easier. It's awesome for collaborating, working on open source, working on projects at hackathons. It's really once you get the mantra down and you get your workflow down, it really makes everything so much simpler. Git's one of my favorite tools. I hope you enjoy using it. And yeah, that's all I got. Thanks for watching.